Hey everyone, this is Connor. I'm going to give you a quick summary of my NESC project. So first I'll start with some of the assumptions that I used when making my schematic. I assumed that substation protection exceeds that of any switch. Usually there are a lot of protections on substations, and the switches that they have available for substations are quite a bit larger than those that you would put on a transmission line. I also made the assumption that solar outputs high voltage. That'll be important later on. I'll go into that. And then I also assumed that BPA has a working relationship with the brother substation. My main finding was that the max fault current was 1,500 amps, and that was calculated by adding all the power from all the sources together and assuming that all of it was diverted down a single line, and then performing a simple power calculation, and you would get 1,500 amps. And this was great because it didn't reach the maximum rated current value for the lowest cost switch available, and so we can use fairly affordable switches for all of the schematic. So to get started with switch choices, my main concern was protecting people in the people spaces from high currents. And to do that, I used a lot of loop switches. Loop switches are designed to prevent high current from flowing down a line. Now, you'll see S2 and S3, S5, S7, and S9, and S16 are all of my loop switches. So the loop switches at S2 and S7 are placed there in order to prevent any high current flowing from the 30 megawatt power generation plants, from reaching the transmission line. S3 is similar idea, but it also includes Brasada. If anything goes wrong with Brasada and the 30 megawatt wind plant, the S3 switch has been sized to prevent that from flowing into any of the loads. Now, S5 and S9 are a little different because these have loop switches because there wasn't any information given about the distance between the Hampton load and the transmission line and the Riley load and the transmission line. And thus, a loop switch was used because it has the highest effective distance. Now, the new taps, the 30 megawatt wind and the 30 megawatt biomass, were placed on the longer portions of the transmission line and split the line in half effectively. And what this did was it was able to reduce that effective distance and allowed for the use of more affordable switches, such as load switches in the case of S6, S8, and S1. Now, going over to the solar, I mentioned how solar outputs high voltage. It also should be noted that these solar plants contain a delta transformer, which will catch any sort of fault current at the plant. Thus, a load switch was used to prevent any sort of issues with voltage variation. Now you can see that in S15 and S12. And then for shorter distances, I was in a way to try to save some money. Bare switches were used because they are only effective on very short distances. So you'll see that in S13, S14, and S4. And yeah, that's about all I have so far. I might tweak it a little bit, and then yeah. Thank you all for listening, and have a good evening.